Okay, so 2.1. So 2.1 functions. So anyone has any idea about function? What is the meaning of function? What is function?
It's a curve for each x value, it has only one y value.
Exactly. Nice. Yeah. So for each x value has only one y values. This is true. Let me start and draw a diagram, explain what is function. So function, it's look like a machine. It has input and it has output. So this is my machine. So this machine is my function. I'll call the function by f, denoted by f. So it has input, x value, and it has output. This value go inside the machine, then will give me output, f of x. So this is my input here, and this is output. And this is like a machine. So every input has only one output. This is what you have to know. Every input, x, has only one output. This is the function. So let me give you the definition of the function, the general definition. So a function is a function f, I call it by f, is a rule that assigns to each element x in set A exactly one element in a set B. Called f of x. Okay. So it's like a machine that connect every point in the set A to another point in the set B. The set A is called domain, and the set B is called range. So what is the domain and what is the range? Let me define the domain and the range. So the domain it is my A set is a set of all possible inputs. Whatever is possible inputs goes inside this machine is called domain. And the range is a set of all possible outputs. Whatever give me this machine output is called the range. Okay. So here I define the definition of function. It's a rule that connect or assign each element of X in a set A exactly one element in a set B. This element is called f of X. I define the domain. The domain is a set of all possible inputs, and the set of all possible outputs is called the range. Okay, any question about this definition? Okay, so let me now graph another way how we can picture a function in a row diagram. So for a row diagram, if I have like set A look like this, it has here element 1, 2, 3, 4. This is 1, 2, 3, 4, and I have this set A, and I have another set is the set B. 1, 2, 3. It has 3 elements. Is 30, 60, and 80. So the one here is goes to, for example, suppose to goes to 3, and the 2 is goes to, I mean, 1 goes to 30, 2 again goes to 30, 3 goes to, for example, 80, and the 4 goes to 60. So look here, every element in the set A goes to one element in the set B. So this is a function. Every element in the set A, 1 goes to 30, 2 goes to 30. Every element here goes to one element in the set B. And this is true. This is a function. So this is called here, I can say every input has one output. So it is a function. And my function here, I call it f. So the function here, I denote it by the letter f. But this diagram, I will draw it right now. This thing's here. 2, 3, 4, 1, 2, 3, 4. This is my set A, and here my set B is have 30, have 60, have 80. This is my set B. This is here. I draw it again by different color. 1 goes to, for example, 60, and 2 goes to 30, and again 2 goes to 80, 4 goes to 60, 3 goes to 60. Look, the number 2 in the domain. Number 1 has 1 value. This is good. Number 2 has 2 value. So this is mean is not good. So this is mean is not a function. Why? Because the 2 here takes 2 values. Takes the value 30 and takes the value 80. 3 takes 1 value. This is good. 4 takes 1 value, 60. But 3 takes 2 values. So this is mean is not a good, is not a function. Why? The function is supposed to be every input has 1 output. So 2 has 2 outputs. The element 2 has 2 outputs. So this diagram does not represent a function. So this is not function. Okay. Any questions so far? So you know now what's the mean of function? Makes sense? It's clear? So every element in the domain must be take one element in the range or in the another set, the codomain. Okay. So now let's go to give you example. So example 1. A function f is defined as f of x equal x squared plus 4. So the first question in this example, evaluate f of 3, f of minus 2, f of square root of 5. Second question, find the domain. And range of f. third question is draw a machine diagram for F. We'll do the first one. Kelly, you want to do the first one?
Can I do it?
Yes.
Okay, so f of 3 is 13.
13. What you do?
I took 3 and squared it, and added 4.
Perfect. So 3 squared, you plug the 3 inside the equation. 3 squared plus 4. So 3 squared is 9 plus 4 is
13.
Yes, this is true.
And f
For the
of
second.
negative 2
Yes.
is 8.
8. So negative 2 squared plus 4. I get negative 2 squared is 4 plus 4 is 8. Yes.
And f of the square root of 5, I got 9.
Okay. So square root of 5 plus 4. So square root of 5 is 5. It's the absolute value for 5, but it's 5 because it's already positive. So 5 plus 4 is plus 4. It's 9. Okay, perfect. Any question for the first one? Just you plug inside the function. You plug the numbers inside the function. For the second one, who will do the second one? Find the domain and range of F.
Domain's all real numbers, right? If there's anything you can put in that invalidates it.
The range, let me go back. The range is the set of all possible outputs. So it's the outputs, the range. And it's, so let's start for the domain. What is the domain? Like, what is the input? What's the possible input? Because go back, domain of A is a set of all possible inputs. So what's possible inputs for this function? What can I plug inside this function?
All real numbers?
Yes, exactly. So if I plug the negative numbers, -1, -2, -3, inside this function, it will be defined. If I plug the 0, also will be defined. If I plug the positive numbers, will be defined. So the domain in general will be all the real numbers. So from 2, the domain is R, all real numbers. Now, what's the range? What's the output for this function?
The range is 13 minus 9.
13 minus 9. Why you choose 13?
Because it's the great. No, wait, it's 13 minus 8. Because 13 is the biggest number and 8 is the smallest. And the range is the subtracting y.
How you find the greatest number here in this function?
So
Because it's the y value.
The y value, but like this for like if which you exactly you plug to get 13. Like how you find that, like the range, it's all the possible output after you plug the element in the domain.
Range is just, isn't it just f of x is greater than or equal to 4?
Greater than or equal to 4. This is correct. Can you explain how you think about that?
Well, no matter what number you put into x, it'll be squared. So no matter how negative you go, it'll always be positive. So the lowest value you can get for the function is by putting 0 into x, which gives you 4.
Nice. So nice. Exactly. This is perfect answer. So like he said, like if I plug the positive numbers, let me go over the function. So the function f of x, it's like x squared plus 4. So I will start from f of 0. I plug the 0. I get 0 plus 4. 0 plus 4, they give me 4. If I plug 1, f of 1, they give me 1 plus 4, 1 square plus 4, they give me 5. If I plug 2, 2 square is 2 square plus 4 is 8. So the number is increasing, 4, 5, 8, and increasing. What about if I plug negative numbers? Negative 1, they give me negative 1 square plus 4, and they give me again 5. And the same things for f of minus 2. They give me minus 2 square plus 4, they give me 8. So look, all the possible outputs, the minimum number for all possible input is 4. So look, the 4 then go up for when I plug any positive number, they give me 5, 8, and go on positive. And increasing than is larger than 4. Same things when I plug the negative, they give me 5, 8, and so on, positives. So the minimum numbers I can start from this function is 4, and the largest number I can get to infinity. So I can set the range all output, all y's, such that y is greater than or equal 4, from 4 to infinity. Or I can set the range look like this, from 4 as like close interval to infinity, open interval. Make sense? So now you know how to think about the range by plugging numbers. Plugging the numbers come from the domain. So explaining to, yeah. So now, okay. Any questions so far? How to think about the range? You plug the possible input, you get the output. So for 0, I start from the minimum one, 0, they give me 4. I plug positive numbers, 1, 2, 3, 4, 5 to infinity, it goes up to infinity positive. I plug negative, they give me the same things like positive. For f of minus 1 is 5 like f of 1. F of 2 is the same as f of minus 2. Same things for f of 3 and f of minus 3. Number 3. Draw a machine diagram for f. So this is mean, draw something like that. Machine. So my function is f. This is my machine diagram. So this is my function f. Here is the input x. Is all real numbers. Here is the output is f of x. It's all the set from 4 to infinity. Any question? Makes sense how we think about this example? Okay, let me give you another example. So the example is evaluate a function. So my function is g of x equal the absolute value for 2x plus 5. And the value I ask to evaluate it is g of minus 3, g of minus 2, g of 0, and g of 1. Who will do the first one? Who will do the first one? G of minus 3. What is g of minus 3?
So 1.
It's 1. So you plug the minus 3 inside this equation, inside this function. So I get 2 times minus 3. By the way, the absolute value, they turn everything negative to positive, and the positive keep it positive, and the 0 keep it 0. So 2 times minus 3 plus 5. So 2 times minus 3 is minus 6 plus 5. Minus 6 plus 5 is negative 1. And the absolute value for negative 1, like I said, is 1. Why? Because it's negative numbers. G of minus 2, who will do it? Who will do the second one? G of minus 2. Who will do the second one? Same
Would be
idea.
it would be 2 parentheses negative 2 plus 5 in the absolute value symbol.
Again, it will be 2 times negative 2, like he said, plus 5.
Yes.
Okay, so 2
That
times
would
negative
equal
2.
negative 4 plus 5 in absolute value, which would equal just 1, and then the final answer is 1.
Okay, perfect. Nice. Answer is 1. G of 0. Same idea. You plug the 0.
5, right?
5. So 2 times 0 plus 5. 2 times 0 is 0 plus 5. They give me 5. G of 1. Same idea. 2 times 1 plus 5. 2 times 1 is 2 plus 5 is 7. The absolute value for 7 is 7. Okay. So the same things, I give you exercise. Same idea for function f of x equal 3x squared plus x minus 5. Evaluate f of minus 2, f of 0, f of 4. So we're not going to do it this in a class. This is for you. Same idea, you plug the numbers inside a function and you get outputs. So let me give you now another example for functions. Before I move to the next slide, it makes sense here, like the previous example. You know how to plug inside the absolute value function.
Yeah, that makes sense.
Okay. So now we have another kind of equations of functions. It's called piecewise functions. So another function is called piecewise function. So for example, function like that, c of x equal 39, and here 39 plus 15 times x minus 2. So this is mean here when if x between 0 and 2, here if x greater than 1 than 2. Piecewise function means a function has two functions inside, but this function has different domain about the other function. This function has domain from 0 to 2. This function has a domain any number is greater than 2. So the question now, evaluate c of 2, c of 1/2, and c of 4. Who will do the first one? C of 2. So you have to check the number inside the function here, c of 2. We go here to this function. You have to check this 2 it's inside the first function or in the second function. Is the 2 between 0 and 2, or is it greater than 2? So the 2 here, it's sitting inside this function. Why? Because the domain here, it's from 0, x less than or equal 0 less than, or x is greater than or equal 0 less than or equal 2. So the equal here for 2, this is mean that 2 is inside the first function. So c of 2 is 39. Is not in the second function because the 2 is inside the first domain of the first function. What about the second one, c of 1/2? Where is the 1/2 position, in the first domain or in the second domain?
The first.
The first. The 1/2, it's inside this function, inside this domain of the function between 0 and 2. So c of 1/2 is 39 again. What about c of 4?
69.
It's, what is it?
I think the value is 69.
69. So he used the second one. Why? Because the 4 is, it's set inside this domain. The 4 is greater than 2. This is mean the 4, we have to use the second function to plug the 4. So this is mean 39 plus 15 times 4 minus 2. 39 4 minus 2 is 2. 2 times 15 is 30. So 39 plus 30 is 69. Any questions so far? So this is called piecewise function. Function has two functions inside. Okay, now let's go to another topic in this section. Is called the net change. So let me give you the formula for the net change. So the net change of a function f of input change from A to B is f of, it is given like f of B minus f of A. So this is the formula for the net change. If I have change of the function of the input from the point A to the another point, so the net change formula is f of B minus f of A. Okay, let me give you example for that. The question is, let f of x equal x squared, for example. My function is x squared. And the question is, find the net change. Find the net change from the first one from 1 to 3. For the second one, from -2 to 2. Who will do the first one? The change for the first one? Just to plug inside this formula. Use this formula. So what is the net change?
It's 8.
8. How you think about this?
So it's what, 3 squared minus 1 squared?
Okay, perfect. So the net change equal f of 3 minus f of 1. Use this formula. So f of 3 is 9 minus 1, because 3 squared is 9 and 1 squared is 1. They give me 8. Who will do the second one? Second one. Who will do it? What is the net change for the second one?
Would it be f of 2 minus f of -2?
Yes, f of 2 minus f of -2.
So that would
Then
just be 4 minus 4,
4 minus 4, and they give me
0.
0. So the net change is 0. Any questions so far? Okay. So now let's go to another example. It's called evaluate a function. So the example is evaluate a function. So my function is look like f of x equal 2x squared plus 3x minus 1. Evaluate for f of a. So first one, f of a. Second one, f of minus a. Third, f of a plus h. Fourth, f of a plus h minus f of a over h. And here h is not equal 0. I will do the first one. Just to plug inside this equation. Who will do the first one? F of a.
It's 2a squared plus 3a minus 1.
So f of a is equal to a squared. We plug the a inside this formula, inside this equation. So I get 2a squared plus 3a minus 1. For the second one, who will do the second one? For minus a. Same things, f of minus a. Who will do it? So you plug the minus a inside the equation. You get 2 times negative a squared plus 3 times negative a minus 1. Simplify these things. I get f of a, f of minus a, sorry, equal 2 times this thing. Minus a squared is a squared, so I get 2a squared. 3 times minus a is minus 3a minus 1. Okay. For the third one, who will do the third one? Who will do the third one? It's the same things. You plug it inside of the function f of a plus h. You plug these things inside x. So what I get? 2 times a plus h, everything square, plus 3 times x, a plus h, minus 1. Okay. These things from previous chapter. This is by using the formula, says if I have a plus b, everything square, this means the first one square plus 2ab, 2 times the first term plus times the second term times plus second term square. So what I get here, 2 times first term square plus 2ah plus h square plus. Now distribute the 3 inside the parentheses. What I get, 3a plus 3h and minus 1. Let's simplify it more. I get 2a square. Let me distribute the 2 inside all the parentheses. So 2a square plus 4ah plus 2h square plus this thing's 3a plus 3h minus 1. Who will do the last one? Who will do the last one? Same idea exactly. So for the fourth one, here f of a plus h, it's already, we do it in the third one. This is the answer. Minus f of a, this is f of a. So we already do it. We already did it in the first one. And h here. So f of a plus h minus f of a over h. They give me f of a plus h, this is number 3. We copy all this to a square plus 4a h plus 2h square plus 3a plus 3h minus 1 minus the first term. So this is minus f of a, it's the first one here, minus 2a square plus 3a minus 1 over h. Simplify it more by distributing the minus inside the parentheses. So I'm going to next slide. So I'm going to distribute the minus inside the parentheses. So now I get 2a square plus 4a h plus 2h square plus 3a plus 3h minus 1. And I distribute the minus inside the parentheses. I get minus 2a square minus 3a plus 1. Everything over h. Look now, 2a and minus 2a, they are cancelled. They canceled each other. And I get minus 3a and I get positive 3a. They canceled each other too. And I get here minus 1 and 1. They cancel each other. So everything left after that, 2h squared plus 4ah plus 3h over h. So I stop until here. Who will give me, how can I simplify these things?
Just divide everything by h. So it's 2h plus
Dividing everything by
4a.
h.
Yeah.
Yes. So by dividing everything by h, or I can taking the greatest common factor for the numerator. So the greatest common factor for the numerator is h. I left here 2h plus 4a plus 3, everything over h. Now the h with the h is cancelled again. So the answer is 2h plus 4a plus 3. Any question for that? I know the last one is like a little bit harder, but if you, it's not that much hard because f of a plus h, we already do it in the third one. F of a, we did it in the first one. Just we copy this one and put it here, and you copy the second one and you distribute the minus inside the parentheses. After you distribute the minus inside the parentheses, you find something canceled each other. The 2a squared with the minus 2a squared. And same things for the 3a and minus 3a, and same things for 1 and minus 1. And after that, you get that. And this is from the first chapter. You can find the greatest common factor for the numerator. It's h. So, and you can cancel this one by this one, and you get this. This is the final.
Professor, you're muted.
Anyone has a question? Okay, so let's go over a new part in this section. It's called the domain and the domain of the function. The domain of function. Again, what is the domain? What is the domain? What is the definition of domain? What's the definition of domain? Let's go back to the previous slide. The domain is a set of all possible input. So the domain, again, is the set of all possible input. So let me give you example, and the example is looking for the domain. So the example is find the domain of the function. Let me do the example in the next slide. So example here. Find the domain of the function. So first one is f of x equal x minus 9 over x. Second one is g of x equal square root of x minus 18. 3 h of x equal x squared minus 3x. Again, the domain is only the input, possible input. Who will do the first one? Or who will give me the idea how we can think for the first one? So what is the domain for the first example?
X is not equal 0.
X not equals 0. What about the numerator? So here he said x not equal 0. This is the domain, like all numbers except the 0. This is true. But let me explain more. We're looking for the numerator here in the top. And we ask ourselves, what possible input we can plug inside the numerator? Negative we can plug inside the numerator? Yes, it's fine. They will be defined. The 0, yes. Negative numbers, yes. Now we're looking to the denominator. So the domain for the here up is R, or real numbers. But the problem here, it's in the denominator. We know in the rational expression, the numerator must be not equal 0. It must be not equal 0. So we're looking for the 0 for the numerator, and we remove it from the domain. Okay? So the 0 for the so here the 0 for the denominator is x equals 0. So we have to remove this point, because if we keep this point, they give me the function undefined. Why? Because f of 0 equals 0 minus 9 over 0, and they give me minus 9 over 0, and anything over 0, it's undefined. So here, the domain, it's all the real numbers except the 0. All real numbers except the 0. Why? Because the 0, it's the 0 for the denominator. Make sense? Who will do the second one? Yes. Who will do the second one? Or who will give me any idea how I can solve for the second one?
Find a value that would make sure that it's not a negative number inside.
Yes, perfect. So for the second one, I know it's radical, and here the root is 2. And I said before, if it's the square root or any root of even number like 2, 4, 6, 8, whatever is even numbers, must inside be positive. So like he said, we're looking for which number here makes this x minus 18 is positive or 0. So g of x equal the square root of x minus 18. So we're looking for the value such that if I plug it inside the x, that make x minus 18 positive or 0. So to think about this, I have to set x minus 18 must be positive or 0 by using the inequality. Now, how can I solve the linear inequality? This is linear inequality. How we can solve it? How we can solve the linear inequality here?
Add a
Let's just
on both sides.
Exactly, I add 18 for both sides. This is linear. I don't have to find the sign. So I get x greater than 18. And this is the domain. So my domain must be any number greater than 18. So the domain is all the numbers from 18 to infinity. Okay, so but if I plug any number less than 18, for example 17, this function will give me error. Why? For example, square root of 17 minus 18, they give me square root of minus 1, and square root of minus 1 is undefined. So this is mean error. So the only possible for undefined for real numbers. So the only possible input for the domain, it's from 18 to infinity. Number 3. H of x equal x squared minus 3x. Who will do this one? Who will do this one?
So that's just all real numbers?
All numbers. So if I plug 0, still defined, positive numbers define, negative define. So here the domain is all real numbers. Or I can say it's from minus infinity to infinity. Okay. Any question about the domain? So by this example, we finish 2.1. So let me now go over 2.2. I give you a general idea about 2.2. I take one example or two examples, then I will stop for any question about material before the exam. So now 2.2. It's graphs of function. Graphs of functions. So now in this section, in this section of this chapter, we're going to graph our functions. So first things, we have to go over how to graph function by plotting point. But before I go over these things, let me give you some types of function. First one is called linear function. Linear function. So the linear function is look like function like that, f of x equal mx plus b. This is linear function, and the graph of this function, it's look like it's a look like line, such that here the domain of this function is not the domain, the slope of this function is m, and like last time I said, if m is positive, if the slope is positive, it will be like this. If the slope look like negative, it will be look like this. Here b is the y-intercept. Y-intercept is b. So the graph of this function, like from last time, it's look like this. If the slope is positive here, it's going to be like this. So here, slope is m and is positive. Here again, this is the x-axis, and this is my y-axis. This is the original point, 0, 0. Second type of functions is constant function. So constant function is a function look like this, f of x equal b. And the graph of this function is horizontal line. So it is a horizontal line. And the graph of this function looks like y equal b. So again, if I have the coordinate, the Cartesian plane, so the constant function, it's going to be like this. If b like that. So here, again, this is my x-axis, y-axis, and this is here b. This is my b, and this is y equal b. F of x equal b, and this is the origin point, 0, 0. This is the second type of function, constant function. Third one is yes. So okay, so third one of the function is called a power function. Is any function of like f of x equal x squared, and the last one is called the root function. It's like f of x equal x to the power 1 over n. It's a root function. Now let me give an example how to graph function by plotting point. Example, graph function by plotting point. So f of x equal x squared. So like exactly like equation from the previous chapter, we're going to take a point, take x point, y point, you plug inside the formula, you get the order per point. So this is my x here. Here, this is my x. Here my f of x equal x squared, and here I get x comma y. Which point would you like to use here? Which point would you like to use? Any option?
2.
2. What else? Negative. Give me negatives.
-1, -2.
-1, -2. So I choose this point, -1, -2, 0, 1, 2, 3, 1, 2. Now just you plug this point inside the function to get the y coordinate for the point. Here, I'm not going to use y coordinate, I'm going to use f of x coordinate, is the same. So you plug the 2 inside this function, f of -2. What is the answer?
4.
4. So the point is -2, 4. -1, you plug it inside the function, you get 1. So the point is -1 and 1. The 0 we plug inside the function
Is 0.
0. So 0, 0. The 1 we plug inside, f of 1 is
Just 1.
1.
And that one's 4.
Yes, 1 and 1. And 2 is the same thing, f of 2 is 4. So I get 2, 4. Now you draw the Cartesian plane. So this is my Cartesian plane here. The x-axis, the y-axis. Okay, so now you're choosing a point. First point is, let me start from 0, 0. So this is my 0, 0 here. And this is my x-axis. This is my y-axis. So this is the 0, 0, 1, 1. So this is my 1, and here is 1. So the point will be look like this here. 2 and 4. So this is 2. And 4 be like here, around here. 4, 1. And negative 1 and 1. So here negative 1. And 1 here. And negative 2 and 4. So negative 2 here. And 4 here. So the graph for this function, it will be like something like that. Like this. Parabola. It's like parabola. Something like that. Okay. Let me make it so like this. So this is f of x equal x squared. Any questions so far for this example? Okay, I'm going to stop until here today. Next time I'm going to give you more examples for how to graph any function by floating point. Any questions so far? Okay, stopping until here.